Hey guys, what's up? I hope you've had a wonderful week. I hope my love, Jesus Christ, is with you and all that you do as He is me. And yeah, so I already recorded this video like earlier today, and it's Friday, like March something, and early March. And what is it? So I already had a recording of this to a Mooki song. Mooki's like an Israeli artist, right? And unfortunately, like, he has like copyrights for his music, so like it's blocked internationally. That's the notification I got from YouTube. So I have to re-record it, and you know, lucky for you, like I get to like narrate it and do it better, and I suppose lucky for me also. All right, cool. So this is a really cool limit. So I guess we can call it the Mooki Limit. The cool Mooki Limit. This is how you spell his name. Okay. Alright, the Mooki Limit problem. And it is lim as n goes to infinity of n factorial to the 1 over n over n. Right? Okay, and so you need two things for this. One is Stirling's formula, right? Stirling's formula. I think it's an I there. Okay, but whatever. Yeah, it is. I know for sure it's an I right there. Stirling's formula, right? And what it says is for large n, n factorial is approximately equal to square root of 2 pi n, and then n over e to the power n. That's Stirling's formula. We also, in addition to this, need the fact that the limit as n goes to infinity of n to the 1 over n is equal to 1. This here, I show you how to prove using the squeeze theorem. So I'll leave you a link to that, right? Okay, but yeah, together with those things, this is easy. Yeah? Okay, cool. So first thing we should do then is be like, oh yeah, this is lim as n goes to infinity. We replace this n factorial with that, right? That's why we wanted to, yeah? Okay, use Stirling's formula. So you have 2 pi n to the 1/2, right, square root. And then it's n over e to the power n. So all that I have written here is a replacement for n factorial for large n, again using Stirling's formula. But all of this n factorial in here is raised to the power 1 over n. That's right there, right? And all of this in turn is divided by n, right? Okay. So, like, what do we do next? Well, we could use exponent rules and distribute this power here and there, right? Okay, so if we do that, we have lim as n goes to infinity of like, I'm like ultra serious in this video, and like I don't even know why. Like okay, I'll get back to the task at hand. I was gonna do a joke, but like, yeah, okay, like the joke like went into thin air. Okay. So like what is it? So we go 2 pi n to the 1 over 2n, right? It's yeah. Okay, and in this part, like the exponent n here and the 1 over n are going to cancel, and so it's going to be n over e, right? And all of this is divided by n, right? Now look here, so we could do this, right? Cancel that n and that n right there. Yeah? Okay, cool. And so then we've got 1 over e here, right? Okay, and so we have a product here between 2 pi and n, and so we could be like, oh yeah, from here we could go here, which is lim as n goes to infinity. I'm taking more steps than I need to, but whatever, we'll do. So 1 over e, that's a constant now, so 1 over e, I don't like that. Okay, 1 over e. Good penmanship is important, at least to me, right? Okay. And then we have like 2 pi to the 1 over n to the 1/2. Like, I'm like undoing. Well, you know what I just do. You should be able to follow. And then n to the 1 over n to the 1/2. You'll see like that there's a method for why I chose to go in that direction. Now we have a limit law that says that we can put the limit inside, right? So in a composition. So I'm going to go 1 over e, which is the same as 1 over e, and then lim, and I'm at the same time as I put the limit in, I'm going to apply the limit product law, right? Because we have a product here and here, and that's why I mentioned earlier, see, like that's called good teaching, yeah? Okay. And limit as n goes to infinity of, so we have 2 pi to the power 1 over n, all of this to the 1/2, and then times limit as n goes to infinity of n to the power 1 over n to the 1/2, right? Okay, now look here. So aquí, right here, we apply this here. So this is equal to 1, right? And this part, it's very obvious that as n goes to infinity, 1 over n goes to 0. So we have 2 pi to the power 0. So we have like 1 over e, and 2 pi to the power 0 is 1. So 1 to the power 1/2 times, well, I just said that that's 1, right? Well, 1 to the 1/2, but I'll write it as 1 to the 1/2 if like it pleases your heart. And so all of this reduces to 1 over e, yeah? Okay, cool. That was cheesy.